Hello wonderful students of MSU who is taking 10-20603, Communication System. Today, let's get into a short lecture on optical communication with Group 1, consist of Asif, Emni, Dan, Nelson, and Abraham. There are three main topics we are going to cover. 1. The element of optical communication. 2. Modes of propagation. 3. Losses in optical communication. Let us dive into it post-haste. What is optical communication? It is any form of telecommunication that uses light as the medium of transmission. They use fiber optic cable as their main way of operation. What is fiber optic cable? A fiber optic cable, also known as an optical fiber cable, is an assembly similar to an electrical cable, but containing one or more optical fibers that are used to carry light. Figure shows the optical fiber coatings or buffers that plays an important role in protecting the fiber from its intended environment. It consists of the one with the red layer which is the outer jacket, the black layer which is the strength member, the gray layer is the coating, the blue layer is the cladding, and the transparent silver is the core. What are the advantages of fiber optic? Capable of transmitting several gigabits per second over hundreds of kilometers. Exhibit less than a few tenths of a decibel of loss per kilometer. Immune to inductive coupling or crosstalk from adjacent copper or fiber channels as it is not affected by electromagnetic interference or electrostatic interference. Light does not radiate from a fiber optic cable. It is nearly impossible to secretly tap into it without detection. The surface of glass fiber is much more refined than ordinary glass coupled with its small diameter, allows it to be flexible enough to wrap around the pencil. It is more resistant to corrosion caused by environmental extremes such as temperature, corrosive gas and liquids. What are the disadvantages of fiber optic? Conversion of electronic facilities to optics to interface with fiber and splicing are costly and can be a tedious task. Fiber has a tensile strength of approximately 1 pound, as compared to coax cable at 180 pound in which where the fiber need is surrounded with stranded Kevlar and a protective PVC jacket to increase the pulling strength up to 500 pound. Need a remote powering of devices as it is necessary to provide electrical power to a remote device as it cannot be achieved through the fiber, hence need to include metallic conductor in the cable assembly. Next is principle of optical communication system. As you can see, figure beside shows the principle of optical communication system as in how it works within the fiber optic, which are by total internal reflection of light method. There are several elements in optical communication. The basic elements are: number 1 light signal which act as the transmitter, number 2 optical fiber which act as the channel, number 3 photo detecting which act as the receiver. The optical transmitter converts the information-carrying electronic signal to an optical signal, which is then sent through a long length of optical fiber. At the receiver end, an optical receiver converts the optical signal back to an electronic signal so that the information is recovered and delivered to the destination. Next is the modes of propagation. Optical communication has 2 propagation and they both perform differently with respect to both attenuation and time dispersion where. Number 1 is single mode where the fiber have a very small core diameter of about 8 micrometer to 12 micrometer diameter and have only a single path of light as it propagate down the cable, plus all light rays follow approximately same amount of time to travel the length of the cable and the model dispersion is 0. As for number 2 is the multimode, where the center core is larger from 50 micrometer to 100 micrometer and it has a large light-to-fiber aperture and allows more light to enter the cable, plus the light rays are propagated down the cable in a zigzag pattern, continuously reflecting off the interface boundary, resulting many paths and making the model dispersion to be present. The image shows how single mode and multi-mode looks. There are pros and cons of a single mode. Where the pros is: Number 1, single mode fiber optic transmissions are faster than multi-mode over long distances because fewer switches or routers are needed mid-span. Number 2, virtually unlimited bandwidth capacity. Number 3, capable of transmitting data at up to 40 gigabits over hundreds of kilometers with little integrity loss. Number 4, over greater distances, such as thousands of kilometers, this cable can send data at speeds of up to 10 gigabits. Number 5, single-mode cable and connectors are generally less expensive than multi-mode. And the cons are: Number 1, single-mode solutions are often more expensive to deploy and operate since laser-based equipment generate more heat. Number 2, the lasers required are costly and can be used with only one cable at a time. Number 3, the dependency on lasers means that single-mode cables are less versatile and more limited in their applications. There are pros and cons of the multi-mode. Where the pros is: Number 1, multi-mode cables are less expensive to operate, install, and maintain. Number 2, high speed and high bandwidth over short distances. Number 3, allow several mode optical signals to be transmitted at once. As for the cons: Number 1, multi-mode cables are more limited in both speed and distance. Number 2, the maximum speed of an OM4 multi-mode cable is 100 G depending on distance, and only up to a distance of 400 to 550 meters. For OM3 fiber the maximum distance is 300 meters. At 2 kilometers, it is only capable of transmitting 100 megabits. What is attenuation in fiber optic? It is noted that when light travels in a fiber optic cable in the long run, light tends to attenuate. In short, attenuation is the condition where the signal becoming weaker when it travels from the source to destination. What happens if a signal attenuates? Number 1, it reduces the system bandwidth. Number 2, it lowers the information transmission rate. Number 3, it reduces efficiency. Number 4, it reduces overall system capacity. Losses in optical communication are mainly associated with: Number 1, cable losses, where the cable length, material and material purity are the main factors. Number 2, connector losses, where connector used to connect two sections of cable and connection not perfect, light energy can escape causing a reduction in optical power. Number 3, source-to-cable interface and cable-to-light detector interface loss, where the mechanical interface used to house the light source or light detector and is attached to the cable imperfectly. Number 4, splicing loss, where when the cable be fused together and the slices are not perfect. Number 5, how the cable bends, where in the case the cable bent at too large of an angle and making the internal characteristics of the cable can change dramatically. How to reduce losses in optical fiber. 1. Make sure to adapt the high-quality cables with same properties as much as possible. 2. Choose qualified connectors as much as possible by making sure that the insertion loss should be lower than 0.3 decibels and the additional loss should be lower than 0.2 decibels. 3. During splicing, strictly follow the processing and environment requirements. 4. The connecting joints must have excellent patch and closed coupling so that can prevent the light leakage. 5. Make sure of the cleanliness of the connectors. 6. Choose the best route and methods to lay the fiber cables during design the construction. 7. Select and form a qualified construction team to guarantee the quality of the construction. 8. Strengthen the protection work, especially lightning protection, electrical protection, anti-corrosion and anti-mechanical damage. 9. Use high-quality heat-shrinkable tube. As a conclusion, Optical fiber technology has been used in many areas of telecommunication, photonics, medical and engineering. It has attracted many researchers due to its performance, low loss, no interference, higher bandwidth and its inherently high data carrying capacity. Although optical fibers have many advantages, there still exist some disadvantages associated with the optical fiber technology. Hence, it is our job as a communication system engineer to investigate this matter and help in improving it more and more. That's all from us. Thank you. Robot voice out.